In a previous video, we've taken a look at how we can use factoring as a way to solve a quadratic equation that involves the area of a rectangle. So let me show you how to do those same kinds of problems using your graphing calculator instead. We could do these next couple examples with factoring, but for this first example with the farm, our numbers are going to be enormous and factoring is going to be kind of annoying. So I just want to show you that you can use your graphing calculator to solve these as well. So in this case, what we have is we have a rectangular field that's 400 yards by 600 yards. And what I want to do is I want to double our current area by adding on a certain amount to the length and a certain amount to the width of the rectangle, the same amount both directions. So let's go ahead and actually focus on setting this up right now, and then we'll go ahead and switch over and use the calculator to actually solve and figure out what I should add on to do this. So here's what we've got. Right now, I guess it's important to note what the area of our field is now. So 400 times 600 gets us an area right now of 240,000 square yards, I think we're dealing with in this case. Yeah, square yards. Our new rectangle, though, is not 400 by 600. Our new rectangle is that long. So it's 400, we're adding x onto it. So I can express the new area as 400, or x plus 400, or 400 plus x. Same idea with the width of the rectangle. It was 600, but I want to add x yards onto it. So my new rectangle, the height is going to be, or width, is going to be x plus 600. So let's go ahead and set up the equation now, and then we'll switch over to the graphing calculator. So, so I've got a length of x plus 400, and we know the area is length times width for a rectangle, and then the width or height is going to be x plus 600, and I want that to be equal to not 240,000, but remember we said we wanted to double our area. So if our area currently is 240,000, I want to double that to 480,000. So if you were going to do this problem by hand, this is the point where you need to set this problem equal to 0, multiply x plus 400 times x plus 600, refactor the problem, and then solve it. It's definitely doable, but the size of the numbers just makes it kind of annoying. So let me show you how we can use our graphing calculator to do this. So what I want you to do is on your calculator, I want you to go into y equals. We're going to solve by graphing. And what I want you to do is enter one side of your equation as y1 and enter the other side of your equation as y2, and we'll find a window that we can see this on, and what we're going to look for is the intersection of the parabola, the y1 side, and the line, the y2 side, and that intersection will be our solution. So let's switch over and take a look at this on the graphing calculator. So as we discussed, we're going to use our graphing calculator to finish this equation by finding an intersection point with the equation that we wrote previously. So I've gone ahead and already typed in the two sides of my equation. Type in one side of your equation as y1, the other side is y2. And what I want to look for is an intersection. Now I know this is going to be a parabola because I see eventually I would have x times x if I multiplied that out, so there's x squared. And then y2 is going to be a horizontal line. 480,000 spaces up. So part of this is going to be adjusting my window so I can actually see my intersection point. So if you hit graph now, you're not going to see anything. So what I need to do is I need to first adjust my window so I can find an intersection. Because I know that this side of my equation is going to be that horizontal line, I know my y max needs to be at least that high to see that horizontal line. So I'm going to make my y max a little bit higher. I'm going to go 500,000. Okay. And if I try that window, let's see if I see anything. I've not changed my x's yet, so let's see if I see an intersection point. So I see part of my parabola. There's it slowly curving upwards, and there's the horizontal line. So this window is terrible. I'm looking for an intersection point, and I can see that that line curves, and eventually somewhere way out there, there'd be an intersection point. So let's go back to our window and adjust this time. Let's make our x max a little bit higher. I could also use the problem to help me figure out what kind of x values would make sense. Remember, x stood for how much land we're adding to our field. Right now it's 400 by 600 yards, and I want to double my area. So I'm guessing adding 10 yards is going to be insignificant. So I need a much higher number. Let's try adding, I don't know, let's try 500 yards. If I don't find an intersection, and if my window's no good, then don't get upset about it. Just try another window. So let's see this time if I can see an intersection point. So there's my parabola, part of it curving upward. There is my horizontal line, and good. I do see an intersection that I need. Now some of you might be thinking, well, what about that other intersection? Like if I follow my parabola backwards, it should also intersect here. Well, I'd have a negative intersection, and I don't care about adding negative area to my field, negative land. That doesn't make sense. So let's find just this intersection point. So hit second and trace if you forgot where to find intersection. Option 5 is what I want. It's going to ask you 3 questions. You can just go ahead and, if you want to trace, although my cursor is way off the screen right now, if you want to trace and get close to that intersection point, you can. Otherwise, just hit enter 3 times for first curve, second curve, and guess, and it'll find you your intersection point. So the solution to this is x equals 200. I should be adding 200 yards onto my field. Now, going back to the question though, they do say what are the new dimensions of the field? Well, let's go back and actually answer that question then. If I add 200 yards onto either side of that field, 400 plus 200 gets me 600 yards. And then this dimension, adding 200 more yards, gets me 800. So my new dimension should be 600 times 800, and if you just want to double check that that is the area you want, multiply it. 600 yards times 800 yards, we were looking for an area of 480,000, and ta-da, we got it. So I want to add on 200 yards, and 600 by 800 yards would be my new dimension. And that's how I can use my graphing calculator to solve this, rather than solve by factoring.